Welcome, everyone. Today, we are diving into an advanced AI architectural pattern, systematic error detection using a red team prompt. We will learn how to deploy one Claude instance specifically to critique, audit, and verify the output of another Claude instance. Let's get started. Let's begin with the concept of systematic error detection. What exactly is a red team prompt? It means deploying a secondary, isolated Claude instance solely to critique and find flaws in the output of a primary Claude instance. The basics involve splitting the task. One agent generates, the other evaluates. Why do we do this? Because relying on a single AI to generate content and review its own work simultaneously leads to blind spots. By separating the generation phase from the critique phase, you reduce the cognitive load on the model and significantly reduce hallucinations. How is it done? You capture the draft output and pass it to a new prompt where Claude acts as a strict auditor. In our deep dive, we see this mirrors professional engineering. The developer who writes the code should not be the only one testing it. Take a look at this architecture flowchart. On the left, your primary prompt goes into the generator Claude, which produces a draft output. Instead of giving this directly to the user, the draft is piped into the red team prompt. This activates the evaluator Claude highlighted in red, which strictly audits the text and produces a critique and verdict. The user only sees the final, audited result. To implement a red team, we use an architecture called prompt chaining. What is this? It involves breaking a complex task into sequential API calls to enforce a specific pipeline structure. The basics rely on the most common chaining pattern for self-correction. First, generate a draft, then have Claude review it against criteria, and finally have Claude refine it based on that review. Why is this powerful? Because each step is a separate API call, which means you can log, evaluate, or branch the logic at any point during the workflow. How do we build it? We create distinct prompts for a drafter and a judge. Our deep dive reveals that using separate API calls gives the judge a completely fresh context window, meaning it won't be biased by the messy thought process the drafter used to generate the text. This sequence diagram maps the exact API flow. The application makes API call 1 to the generator Claude, which returns a draft. The application then initiates API call 2, passing the draft to the red team Claude. The red team returns specific flaws and feedback. Finally, the application makes API call 3, feeding that harsh feedback back to the generator to refine the draft, resulting in the final polished output. The success of your evaluation entirely depends on crafting the red team persona. What does this mean? It means assigning a specific adversarial role to the evaluator Claude. The basics involve using titles like Senior Compliance Auditor or Ruthless Fact Checker. Why do we need to be so aggressive? Because by default, large language models are trained to be helpful and polite. Setting an adversarial persona bypasses this agreeableness and forces the model to actively hunt for failures. How do you do it? You explicitly write a system prompt stating you are a strict QA reviewer. Your sole job is to find factual errors. Do not fix them. Only report them. Check the sample code on the slide. By instructing Claude to only report flaws, you ensure it stays focused on auditing rather than trying to rewrite the document itself. This mind map illustrates the 4 pillars of a perfect red team prompt. You must define the persona, ensuring it acts as a strict auditor with zero politeness. You must provide strict instructions to hunt for errors, but not rewrite the text. You must supply the input data, including both the original rules and the generated draft. Finally, you demand a strict output format, ideally returning a pass/fail Boolean for your application to parse. A good auditor needs a rubric, which brings us to targeting specific error categories. Never give the red team a vague instruction like, check for mistakes. The basics dictate that you instruct the evaluator to hunt for 4 specific things: factual errors, logical inconsistencies, tone mismatches, and requirement deviations. Why? Because an LLM needs explicit boundaries, otherwise it might flag your stylistic choices as objective errors. How do we ensure accuracy? You can use iterative refinement and ask the red team Claude to verify each claim by finding a supporting quote from the source material. If it can't find a quote, it must flag the claim as a hallucination. For our deep dive, consider security. You can deploy a red team prompt specifically to scan user-uploaded documents for hidden prompt injections that might try to hijack your main agent's reasoning. Observe this decision tree for the red team evaluation. When analyzing the draft, the evaluator performs a category check across 3 branches. It checks factual claims against the source docs, flagging any hallucinations. It checks logical flow for internal consistency, flagging contradictions. and it checks constraints against the original user prompt, flagging missing requirements. This structured approach leaves no stone unturned. To automate this pipeline, we must enforce structured evaluation outputs. What is this? It's using Claude's capabilities to force the red team to return its evaluation as strict, parsable JSON. The basics. We don't want a conversational paragraph saying, "I think this looks okay." We want a programmatic data object. Why? Because your application code needs to definitively read a true or false value to decide if it should deliver the text to the user or send it back for a rewrite. How do we achieve this? You can use the structured outputs feature by defining a JSON schema, ensuring Claude returns exactly the keys you request. Look at the sample code. We demand a Boolean for approved and an array for critical flaws. If approved is false, our code automatically captures the flaws array to trigger the next step. This state diagram shows the programmatic control flow. The red team analysis state transitions into JSON generation, strictly enforcing the schema. The resulting JSON hits the app parser. Inside the parser, we check the Boolean. If true, the system state moves to deliver to user. If false, it reads the flaws array and transitions to trigger rewrite. This is how you build reliable, autonomous pipelines. Once we have our list of flaws, we enter the iterative refinement loop. What is this? It is taking the red team's critique and feeding it directly back to the original generator Claude to fix the mistakes. This closes the loop. The basics involve prompting the generator with its own draft, alongside the red team's harsh feedback. Why is this so effective? Iterative refinement catches and corrects inconsistencies because it is vastly easier for an LLM to fix a known, documented error than to generate flawless text on the first try. How do we prompt this? We say, "Here is your previous draft, and here is an auditor's critique. Rewrite the draft to resolve all listed flaws." For our deep dive, a critical engineering warning, always implement a max retries counter in your code. If the red team rejects the draft 3 times, halt the loop and escalate to a human to prevent infinite, expensive API loops. This flowchart maps the safety of the refinement loop. The original draft hits the red team evaluator. The approved diamond routes the logic. If yes, we get our final output. If no, we extract flaws and hit our safety check, max retries hit. If yes, we escalate to human. If no, the generator Claude fixes flaws, and the new draft loops recursively back to the red team evaluator for another pass. Let's apply this to a real-time, high-stakes use case, the financial report auditor. Imagine a financial services firm using Claude to generate quarterly performance summaries from raw CSV data. The risk here is massive. A single hallucinated revenue number could lead to catastrophic regulatory fines. The solution is our red team architecture. The generator instance writes the 3-page summary. Then a red team instance is deployed, role-playing as a strict SEC compliance officer. Its sole execution task is to cross-reference every single number in the draft against the original CSV data. The outcome, the red team successfully catches a hallucinated projected growth rate. It rejects the JSON payload, forces the generator to remove the unverified claim, and rewrites the paragraph. The error is neutralized before any human ever sees the document. This sequence diagram shows the financial workflow. Raw CSV data is fed to the generator, acting as the analyst. The analyst submits the Q3 draft to the red team, acting as compliance. Crucially, the red team securely cross-references the metrics back against the original raw CSV data. It detects the hallucinated metric, rejects the draft, and forces the generator to fix paragraph 2. Only the fully audited report is delivered to the human financial officer. Let's wrap up with the most critical best practice, the human in the loop. What does this mean? It means maintaining human oversight as the ultimate arbiter of quality. The basics, a red team AI is incredibly powerful, but it is still an AI. It can occasionally miss nuanced contextual errors. Why do we need this? To establish an enterprise-grade safety net. How do we do it? We implement what experts call the 3-layer quality system. Layer 1 is Claude's initial generation and self-check. Layer 2 is our rigorous red team AI review. Layer 3 must always be human judgment and final polish. The AI handles the heavy lifting of finding 99% of the errors, leaving you to make the final strategic decisions. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final diagram illustrates the 3-layer quality system. Raw data enters Layer 1, the generator Claude. The output flows to layer 2, the red team Claude. If an error is found, it loops back. If no errors are found, it hits the crucial layer 3 highlighted in green, the human expert review. Only after passing the human gate does the content proceed to a production release. Trust, but always verify.